Hello friends. This question based on the fundamental property of fluid that is called viscosity, and the question says the viscometer which has 75 centimeter long and it is made by the two concentric cylinder. The outer radius of inner cylinder which is 7.5 centimeter and the clearance between the cylinder which is 1 mm. Now the cylinder is rotated at 300 rpm and the torque is given which is 0.8 Newton meter. Then we have to determine the viscosity. So the viscosity which is the internal resistance between the two layers of the fluid and the shear stress tau which is the directly proportional to the rate of shear strain. This is rate of shear strain, that is this is proportional to the d phi by dt, and it also proportional to the velocity gradient, that is du by dy. So if we remove the proportionality sign, then there is a constant which is mu, and this is du by dy. So this is called viscosity, that is mu is, this is viscosity. And if we assume the velocity profile is linear, that is assuming the velocity profile is linear, because the clearance is very small, so we can assume it that is velocity which is the linear. So then the tau will be the, that is shear stress, which is proportional to the v by h is the clearance between the two layer of the fluid, that is inner cylinder and outer cylinder, that is. So h is clearance between cylinder. Now it is cylinder, so the shear force which is given by the shear force which is the tau shear stress into area, and this is the wetted area. So we know tau is, this is mu v by h, and v can written as r into omega. So this is tangential velocity, v is, so v is tangential velocity, and a is area of wetted surface, that is wetted surface area of inner cylinder. So now we substitute these value in this equation, that is shear force equation. So this is F is equal to the, this is tau which is mu r into omega into h into area which is the 2 pi into r into L. So this is 2 pi r. Now the torque which is the shear force into arm length, that is L, which is, sorry, this is R, this, so the torque which is the mu r into h into 2 pi r into L into R. So the torque, which is the this is the mu 2 pi r cube omega L upon h. This is the final formula for the cylinder. So now it is given that the radius, which is the this is the 7.5 centimeter, which is the 0.075 meter, and the L, that is cylinder length, which is the cylinder length, which is 75 centimeter, which is the 0.75 meter. The clearance, which is h, this is clearance, which is given as 1 mm, that is 1 into 10 to the power minus 3 meter. Now the RPM, which is 300, so omega, that is angular speed, is 2 pi n by 60, which is 2 pi n is 300 divided by 60, which is the 31.415 radian per second. Now torque, which is given as 0.8 Newton meter. Now we substitute these value in this equation, that is mu is equal to, here we get mu is equal to T into H divided by 2 pi r cube omega into L, which is the 0.8, 1 into 10 to the power minus 3 divided by 2 pi into 0.75 cube into 3.415 into 0.75. So here we get viscosity, which is the 0.0128, this is Pascal second or Newton second per meter square. So this is the required viscosity of the fluid. Thank you.